So welcome to protest-stricken Hong Kong. Since all of you guys in my class always had problems with complex numbers, I'll do some stuff on complex numbers now. So yeah, let's get into it. The most important formula is Euler's formula. This is e to the ix equals cosine of x plus I sine of x. So let's have a look at e to the minus ix. So e to the minus ix is cosine of minus x plus I sine of x. And now let's minus x. So let's remember the identities of cosine and sine. We have cosine that starts here and goes like that with a periodicity of 2 pi. And it also looks the same over here. So this is an even function, therefore cosine of x is cosine of minus x. So we might as well take this away. And then the sine, we have a similar phenomenon there. It starts here, goes like that, and then it goes down on here like that. So the sine of minus x is just the minus sine of x. Therefore, these identities hold. And now let's play around with that a little bit. So let's add these both together. Then we get e to the ix plus e to the minus ix equals 2 cosine of x. And now plus, minus cancels out, so we're stuck with cosine. And that's pretty helpful if you want to evaluate some functions. Now let's have a look at what happens if we subtract these guys from each other. We'll subtract one from the other. Therefore, we get e to the ix minus e to the minus ix equals 2 sine of x, right? Yeah. Times I, because nobody ever likes that I. We'll just put it over here. So you usually see it like that. That's sine of x, and that's cosine of x. So these are some identities we're going to use soon, and now let's jump into some calculations. How's the time? How many?
3 minutes.
3 minutes, perfect. So, yeah, how about the easiest example first, just polynomials. A complex function of z equals z to the 4th power, where z is just a complex number. Now we can rewrite this as x plus iy, that's just our complex number in the complex plane, x coordinate, y coordinate, you guys know that. So that's the number here. This is I, imaginary axis, real axis. So yeah, maybe should have done these with different distances, but you get the idea. This to the 4th power. So let's have a look at the factors. The factors are in the triangle of Pascal. So you know this guy, this is just a plus b squared equals a squared plus 2ab plus b squared. That's that. And now let's go a bit further down the road. This is to the 3rd power, and this is to the 4th power. So this is what we need. We get, when we ix this thing on that stuff, x to the 4th power plus 4ix y to the 3rd power plus 6i squared x squared y squared plus 4ix y to the 3rd power plus y to the 6th times I to the 4th. right? Right. Now what's I again? I squared is minus 1. I to the fourth is just I squared times I squared. Therefore it's 1 again. And we can just leave this guy here. This guy is minus 1. So we put a minus here. This is just I times I squared. So therefore minus I. Yeah, sorry for the messy stuff. I didn't sleep a lot. But I had some spicy food, so really crazy. Yeah, and this guy is just 1. All right. So what can we do with this function? We can see if it's analytic. What's analytic? Analytic is if, yeah, it's some nice stuff. I'll just do it and you can look it up because the video gets too long. I obviously know how it's defined, but we'll get into that in another video. So if you want to have a function that's analytic, you'll just write the function as u in terms of x and y plus I times the v of x and y. By the way, how are we doing on the time?
Like 6:35.
Okay, I'll hurry up. Then we can derive this in terms of x, in terms of y, and then we can derive this in terms of x and y. So then you can prove some stuff and you can go to the lecture and hear all about that. And some Cauchy, the great French mathematician, found out that a function is analytic if the derivative of u in terms of x equals the derivative of v in terms of y, I believe, and then du in terms of dy is just minus dy dx. And then we can rewrite this in a short form. This is y, vy, this is minus vx, this is uy, and this is ux. So let's do the partial differentiation. Ux is all of this differentiated with respect to x. So we have ux. Sorry. We should rewrite this as like the real part and the imaginary part. So x to the fourth minus 6 x squared y squared plus y to the 6th plus I times 4 I x y to the 3rd minus 4 I x y to the 3rd. Is that it? I think so. Yeah, that's it. It's a little sleep, sorry guys. So this is our u, this is our v, and now let's differentiate it. X to the 4th is, do you know that? You do? Okay, it's 4x to the 3rd minus 6 times 2, 12x y squared. This is ux, and now vy is nothing but 12x y squared minus 12x y squared. This doesn't really make sense. Should we derive it with respect to x? Maybe. Alright. Yeah. I guess I had too much tear gas yesterday. I'll look that stuff up. I'll come back to you. Maybe this formula here is a bit fishy. I'll do another video. We'll do another video. Have a nice life. Don't get caught by the police. Free Hong Kong.